Hello everyone, welcome back to Dataset and I hope you are doing very well. In this video, we are going to work on very practical and real-world data engineering scenario using Microsoft Fabric. We will be building a complete end-to-end data pipeline using the bronze, silver and gold architecture, which is one of the most popular and modern approach used in real enterprise project. To make this demonstration realistic, we are using a public healthcare dataset from the New York State Open Data Portal, the Hospital Inpatient Discharge dataset. This dataset includes information such as facility name, age group, gender, length of stay, total charges, total costed, and many more attributes. It's a great dataset for analytics and transformation because it gives us a real world structure and complexity. So what are going to learn in this video? How to create bronze layer, silver layer and gold layer in Microsoft Fabric Lakehouse, and how to ingest raw data into bronze layer, how to clean and standardize dataset in silver layer, how to build business friendly analytics table in gold layer, and finally how to run transformation using Microsoft Fabric notebook. So by the end of this session, you will clearly understand how a real life data engineering pipeline is designed and executed using Microsoft Fabric. So before going forward, I request you viewer to please subscribe this channel and like this video if you find this video helpful to you. Now let's get started. I'm in the home page of Microsoft Fabric. Let me create dedicated workspace for this project. So under the workspace here, I will create a new workspace and I will call it health data project. So I will click on here new workspace and let me type here health data project. Okay, and let me click here apply button to create workspace. Okay, here workspace created, and I will also create a new Lakehouse. Let me click here new item and search here Lakehouse and click here Lakehouse, and let me name this health and let me prefix LH means Lakehouse, and let me enable schema. Okay, and click here to create Lakehouse. So I have created dedicated workspace and also created under workspace health data workspace, and here is the Lakehouse. Before we dig into our project, let me quickly introduce dataset we are using. We are working with Hospital Inpatient Discharge SPARCS de-identify 2016 dataset published on New York State Open Data Portal. Okay, I will put this link in description box. It's de-identify dataset of inpatient hospital discharge record for facility in New York State. So no protected patient identifier. So it's safe for public uses. It's included like field, facility name, age, you can see here, facility name, age group, length of stay, total charges, total cost, around 34 column. Okay, other hospital related metrics. So because it's de-identified, it's excellent for learning, analytics, modeling, performance, benchmarking and data engineering demos like the pipeline we are building. For our purpose, this dataset gives us a realistic structure, raw ingestion and cleaning and transformation and reporting all steps of data lakehouse scenario. So with this context in mind, let me export this dataset. Click here, export. Okay, and in format CSV and click here to download. Okay, around 2.34 millions row. Okay, so let me download. It's initiate, it's take around 10 minutes. Okay, so I have already downloaded and you can see here downloaded file around 1.05 GB. Okay, so now let me go to our fabric and let me go to our workspace, and here I am using which we created previously health dataset, and go to here Lakehouse and let me also create new subfolder. Okay, so called it landing, and let me click here to create this folder, and click here this 3 button and let me go to here and let me upload file. Okay, click here, go to location. Okay, and this is our file. Let me click here and open. Okay, and let me upload. So after a few seconds, file has been loaded to our landing folder. Okay, so let me close this. Now that we have understood our data sets, let's go ahead and create a schema that we will use throughout this entire demonstration. In a typical lakehouse architecture, we organize our table into 3 logical layers: bronze, silver and gold layer. So before loading anything, it's always good practice to set up a clear folder and schema structure. This helps us to maintain clean data and make easier an entire pipeline much easier to flow. Now let's create a bronze schema. Go to here and click here 3 dots and simply create here new schema and called it bronze. Okay, this is where our raw CSV file and health dataset will be loaded initially. Okay, let me create here bronze layer successfully created. Okay, next let me create silver layer. Go to here and click here 3 dots, new schema, named it silver. So here I am creating silver layer called silver, which will store clean and refined dataset that is ready for analytics and transformation for this schema. Okay, so let me create here silver layer successfully created. Finally, let's create now gold layer. So again click here 3 dots, let me create new schema and called it gold. Okay, let me create gold layer where all our final output table and delta table will be stored. So now we have bronze layer, silver layer and gold layer. In bronze layer, raw data is stored. In silver layer, clean and transformed data is stored. And in gold layer, business ready analytical table will be stored. So with this structure in place, we can now start loading our data into bronze layer and build our pipeline step by step. So let's move forward. So friend, now let us create bronze layer transformation, which represent data ingestion, where the bringing data exactly as it is. There is no transformation, no cleaning required. So first let me create notebook for bronze layer. You can create notebook from here, open notebook and new notebook. And you can also create notebook from Workspace. Go to Workspace, health data project, Workspace, new item and search here notebook. Okay, and let me click here to create new notebook. Let me call this notebook bronze layer demo. Okay, let me click here. You can see here notebook created. If you create this way notebook, then we need to add here Lakehouse also. So let me click here, add item, existing data source, and let me use LH_health Lakehouse, which we using in this session. So let me connect to this notebook. Okay, and let me also create some cells. And if you see here, here is the bronze layer, silver layer and gold layer, and we have a landing folder in which we have a file called hospital inpatient discharge. So let me copy first AVFS path and store in one variable in single quote. Let me run this while executing, and here is session started within 5 seconds. And let me load this in our data frame using spark.read.format, which is our file is CSV. So write here CSV, and also use here option for header. Write here header, which is going to be true, and use here load and use here file path, which is fl_path. Okay, and let me write here fl_path. Okay, and let me also use here display function, which preview our data frame using display function. Okay, So now you can see here we successfully read this file, hospital inpatient discharge. Let me collapse this, and this is the preview of our data file. Okay, now before doing anything else, let's inspect our data type or schema. So let me write here command df.d type. This command helps us to understand what kind of data type are automatically inferred by our Spark. So you can see here, this is column name and this is string data type. You can also use df.print schema and execute. In this way, you can also see here column name and this is data type. It infer automatically for all column only string data type. Okay. So later on in silver layer we can transform this data type. Okay. Now you will also notice that many column have a space. You can see here many column have a space and a special character like hyphen that can cause an issue in SQL query later. So let's clean them up programmatically by replacing this space with underscore. Okay. So click here and write here for call name in df dot columns. Okay, and df equal to df dot with column rename. So I want to rename this column with call underscore name, call underscore name. This is the column name. Okay, and dot, let me use here replace function. What I want to replace, I want to replace space with underscore. Okay, and also replace here one of the hyphen with underscore. So let me also use again here replace function and write here hyphen and replace with underscore. Okay, so let me now execute this command. So this simple loop replace the space and hyphen with underscore for all column. So this simple loop replace the spaces and hyphen with underscore. So let me verify again. Let me again run this command again. Okay, and you can see here now space is replaced with underscore. And you also notice that here is the 3 underscore. So let me also copy this column. Okay, and let me again df equal to, let me use df dot with column rename again this function, and let me write this column name and let me rename this column name with simple 1 underscore. Okay, to clean up data. Okay, now if you again this run this command df.print schema, this is also replace 3 underscore with 1 underscore. Okay, now we are ready to save this clean data set in bronze layer table here. Okay, so let me click here to for new cell and let me use here df dot write dot mode is, let me use here overwrite and format is here delta format to create table. So let me use here delta and save this as a table. So let me call this bronze, let me call this table name as a bronze health data. Okay, and let me execute. So if you save without any fully qualified table, then this table save in dbo schema. So I am intentionally using only table name, and if you want to save in bronze schema, we need to use here fully qualified table name. So we need to use here, let me first check where it's saved. Let me refresh this, and if you refresh this, you can see here is table created. Okay, to save in bronze layer, we need to use here fully qualified table name. So first we need to use here lh dot health dot, which is our Lakehouse name. Then we need to use here schema name, which is bronze. Okay, and Now execute. Okay, after 13 seconds this table is now created in bronze schema. If you again refresh this and go to here, now you can see here this table created in bronze schema. So let me first delete this in dview schema. Okay, only we have created here bronze table in bronze schema. Okay, so let's verify record. You can read this table by using df equal to spark dot sql, and let me use here select count star from table. Let me copy table name from here. Okay, copy and paste here, and let me also use here display function, display df. Okay, and let me execute. We need to use here in quote, so let me use here single quote. Okay, or double quote you can also use. Now let me execute. So friend, we have successfully completed our bronze layer. The row and structure data is now stored as a delta table loaded from landing folder into bronze layer as a delta format. Okay, now let's move on to silver layer transformation, where we can perform data cleaning, standardization and transformation to make data ready for analytics. So first let me create a new notebook. Go to here health data and let me create notebook this way. Open new notebook, and let me name this notebook. You can click here show me, or you can also rename from here. So let me use here show me and name this as a silver layer. Okay, demo. Okay, and close this. Let me copy bronze layer table path. Go to here bronze layer, click here 3 dot and copy path, and create here variable bronze table path. Okay, and also read and create here data frame using spark dot read dot format, which is delta, and let me load using our path variable. Okay, and let me also display. Let me use here display command to preview our data frame. Okay, and execute this. Let me delete this column. Okay, for silver layer notebook, here session is started. We successfully read data from bronze layer, and this is the preview of our data frame. Okay, so before doing anything, let's inspect our column for this table. So let me use here column and this return list of column. Okay, so before cleaning, it's good idea to check for missing or invalid value. We will use here function like when in is na and count. Okay, so let me import first function by spark dot sql dot function. Let me import is nan when count call. Okay, and let me use here our data frame bronze underscore df and select some key column, and here I am going to use here for loop. So let me use inside our list, and let me delete. First I am going to use here for loop for c as a variable in here list of some column. So list of some column I want to check here. Let's use here age group, paste here. Let me use here gender, and let's suppose I want to use here length of stay, and let me use here also total charges. Okay, so let me use here count function. When here we need to apply here condition. So condition is call C as a variable for column name and is null. Okay, and open bracket, this is a function, or let me also use here not a number function is nan. Okay, and for C comma C for column alias, and give here alias name as a C. Okay, and let me also use here show function to display this. Let me execute. So you can see here this small block of code help us to identify how many nulls exist in key column like age group, gender, length of stay and total charge. So this is very handy profiling step. Okay, now let's move on and let's fix formatting problem like extra space, inconsistent casing and currency symbol. In you can see I want to replace this dollar sign and comma in total charge, total cost. Okay, so let me do here some cleaning in silver layer. Okay, so let me use function like from PySpark dot SQL dot function. Let me import some cleaning function like trim, like upper function, and let me use here regular expression for replace dollar and comma. Okay, so let me now use here also create clean underscore df and browse df, and let me use next line dot with column, and let me I want to trim this string column. So age group I want to trim using trim function, and let me use here call function and put here column name age underscore group. Okay, and let me also use here some other upper function like I want to convert all value from gender to M and F. So let me use here column like gender and use here upper function call, or also let me use here trim and now call and use here gender function. Okay, backward slash, and now let me use here next column like total charge to replace dollar and comma. Okay, so let me copy this column from here, total charge, okay, comma. Now let me use here regular expression replace function. Okay, and in first argument here column name, so use here column name. Second argument you can see here pattern, so let me use here pattern in single quote. Let me use here square bracket. I want to replace dollar and comma. Okay, and third argument I replace with nothing, so put here single quote, double quote, nothing I want to replace. And also let me cast this as a double data type. Okay, backward slash, I also want to convert this total cost same way, so let me copy this and paste here. Need to use here comma. Okay, and copy this column name total cost. Okay, and also I want to convert in double data type, and let me also use here with column. I also want to convert this length of stay into, you can see here this is a string, I want to convert this into integer. Okay, so let me copy this length of stay column and convert this into integer data type. How to convert? Simply use here call function and use here cast. Okay, and put here int. Okay, in same way I also want to convert worth weight. So this is column name weight, and let me use here call function and put here worth weight and cast this into, let's suppose, double. Okay, and now let me execute, or also use here display function and clean df. Okay, so here need to enclose with single quote. Now execute. Okay, so here what happening, we trim age group from text field. Okay, and gender convert in uppercase to consistent like M and F. Okay, you can see, and total charge I remove here $sign and comma, and also convert some numeric column to proper data type like integer and double for length of stay and weight. Okay, now let's create some new column, like here is a drive column I want to create here. So let me use add derived column or metric. Okay, now let's create a new column called cost per day, which is drive column, total charge divided by length of stay. So let me use here let me create here new data frame, transform df equal to clean df. I'm using here with column, and let me use here cost per day, or you can use here cost per day. Okay, and how to create, let me use here call function, and this is total charges divided by call length of stay. So let me copy this from here column name. Okay, and paste here. Okay, and also use here some round function only for 2 digit. Okay, let's use here 1 digit. Okay, and first import here round function from PySpark. So let me use here from PySpark.sql function import round. Okay, and let me execute. So this gives us an extra metric that will be helpful in our report later. Okay, finally let's save our clean and transform data as a silver table. So let me use here transform dot write dot format as a delta. Okay, and save as table as a, let's call this silver health data. Okay, now let's me execute. So this will save in DB schema. So cancel this and let me use here fully qualify table name. So LH underscore health dot silver dot table name. So we need to use here first Lakehouse name, then schema name as a silver, and then table name. Okay, now execute this. So this will save in our silver layer schema. Okay, so now let me refresh. So you can see here we have a refined and analytics ready dataset in our silver layer. Okay, now let us move on to gold layer transformation, where we design for business ready and analytics optimized data. So you can model and aggregate or enrich data. It's depend on your reporting needs. So let's go step by step, where we have several alternative and advanced transformation we can apply in your gold layer transformation. So let me create new notebook for gold layer. So let me go to Workspace, data, new item, search here notebook. Let me click here to create new notebook. Let me name this gold layer. Okay, and let me click here create button to create gold layer. Let me attach Lakehouse, existing Lakehouse. Here I am using LH data. Let's connect. Okay, and you can see here we have bronze table, silver table, Now it's time for gold layer. Okay, now let's first load silver data again to Spark notebook. So go to here, silver and silver table, and you can see here three dot, click here, and you can see here load data to Spark. So let me click here, read data. This time Spark, instead of spark.read.format, here I am using spark.sql and select star from Lakehouse name, schema name, and this is silver health data table name. So let's remove here limit clause. Okay, and let me rename this data frame as a silver df. Okay, and let me also paste here in display, and now let me execute. Let's delete first one. Okay, so we successfully read silver table in our Spark session. Okay, so let me first create one dimension table, hospital dimension table, distinct name of facility. So how we can create? Let me first create data frame dim hospital. Okay, and let me use here silver df dot select. Here I am using selecting facility name. Okay, and let me use here distinct command, and also rename this using with column rename. Okay, and let me use here first facility name. Okay, and I'm going to rename this with hospital name. So let me use here hospital name. Okay, and let me write this data frame. Okay, format here delta, and let me save as table and name this table as lh health dot gold dot name this dim hospital. Okay, hospital, and also enclose with single quote. Now let me execute. So this will create a unique list of hospital name, and our table name is dim hospital. Okay, so let me refresh this, refresh all resource. Okay, and go to again, let's wait for a while, and you can see here dim hospital table is created. Okay, now let us create aggregated summary table to speed up reporting in Power BI. So here I am going to create average cost by hospital and age group. So let me create new code cell, and let me import some function, required function from PySpark.sql dot function, importing here average, and let me also import round function. Okay, so let me create gold summary table equal to, let me use here silver underscore df data frame which we create here. Okay, and then now let me use here dot group by function, and now let me use here facility name column, let me write here name, and also use here age group column, age e group. Okay, and now let me use here backward slash dot, let me use here agg aggregate function, and now let me use here round, and now use here average function for total charges, total charges up to 2 digit. Okay, and give a alias name as average cost per stay. Okay, and let me also create other, let me use here round first average, and use here length of stay, other parameter for this is 2 digit, and give alias name as average length of stay. Okay, and now let me display this data frame first gold summary, and now let me execute. We successfully created here facility name, age group, average cost per stay, and average length of stay. You can also click here to create new chart. Okay, and you can see here average cost per stay, and this is box plot. Let me use this one. Okay, now let me also save this data frame as a table in our gold layer. Okay, so let me click here and let me use this data frame, and let me write to our gold layer, write dot format dot delta. Okay, and save as table, and let me use here fully qualified table name. Okay, so LH health dot gold dot table name, let's say gold hospital summary. Okay, now let me execute. Let me refresh this, and you can see here table is created. Okay, so this table directly can be used in Power BI for quick dashboard. Now let's move on to create enriched fact table with drive matrix. Okay, so let me create new code cell. Okay, so let me first import some required function from PySpark.sql dot function, importing here when, and let's say call function. Okay, so first I'm going to create profit margin and high cost flag. So let me first create fact in this data frame. Okay, let's say this, and let me use here silver data frame which we created here, first data frame. Okay, and let me use here backward slash for clarity of code, and now let me use here with column, and let me say this column name as a profit margin. Okay, and now let me use here call function, and let me use here total profit margin is total charges minus total cost. So let me use here total charges column and minus call total cost. Okay, let me execute or create other table, other column with column, and now let's say other column name is a high cost flag. Okay, and which is going to be, let's use here when function, and inside this let's use call function for column name, and let's say total cost or total charges, let's say if greater than 50,000 then let's say yes, otherwise let's say no. Okay, now let me display this first. Let's use here display function and fact in this table, and now let me execute. Here we create two column, two extra matrix drive column at the end of this profit margin and high cost flag. Okay, so here yes if total charge is greater than 50,000 and no or less than 50,000. Okay, now let's save this fact in this table in gold layer. Fact in this table, write dot format in delta, and now let me use here save as table, and use here LH health dot gold dot, let's say fact discharge enriched. Okay, and let's enclose with quote. Okay, now let me execute. So here we created successfully fact discharge enriched table. So if you refresh this, this will created in gold layer schema. Okay, here you can see here. Okay, so viewer, as you see, the gold layer is not just a place where we dump final data. It's layer we can save data for business use cases, improve performance, and prepare insight for analytics and machine learning. So in this video we covered a nice real world transformation pattern you can apply in your own fabric projects. So viewer, I request you, if you find this video helpful, don't forget to like and subscribe and share. I would like to see you in the next video. Thank you for watching. Have a nice day. Thank you.